Okay, how's everybody doing today? Wow, we seem really excited. All right. But we're just going to continue. It's going to be a normal week. We started arithmetic and geometric sequences yesterday. We'll see how far we get this week. We may have to wait until series for next week. But one thing we started talking about yesterday was if a sequence diverged or if it converged, and I think people were a little confused about that. So I decided to go back, pull some material from rational functions to help us decide, what was going to be happening. So the basic idea, if the sequence approaches one specific number, okay, then we're going to say it converges. If it does not approach a specific number, then it's going to diverge. Okay. Now, how is that going to help us here with these rational functions? Well, what we're going to be doing is trying to ask the question, is there a horizontal asymptote or is there a slant asymptote? Because a lot of our sequences can be written in the form where it looks like a rational function. Okay. You guys remember the rational parent? 1 over x. Do I need to sketch that or are we okay? Sketch it? Okay. Remember 1 over x looked just like this. Okay. We had asymptotes on the axes and then we had branches that kind of did this. Okay. So when I'm talking about this graph here, this one would converge. If you think about the y value being the actual term in the sequence, so like the first term, second term, third term, and then you have the corresponding y value, right? Well, you'll notice this asymptote is here for a reason. That branch is going to get closer and closer to it, but it won't ever touch, right? So here the asymptote represents 0. So this would be an example of one that converges. It approaches a specific number. It may not ever reach it, but that's okay. It doesn't have to. Okay. Now let's think about this. It's going way back to, I want to say, like first or second 6 weeks. So a little bit of time ago. We used something to help me figure out if there was a horizontal or a slant asymptote. And it started with a D. Does anybody remember? There was another word for power. What's that? Degree. There we go. So we were looking at the degree. The degree. Yes. Okay. So there were 3 cases we wanted to go ahead and take a look at. Okay. What if you look at the degree of the numerator and the denominator? So let's say this is case 1. That's exactly right. Okay. Let's say degrees are the same. The degrees are the same. Okay. Well, if the degrees are the same, guaranteed this guy's going to have a horizontal asymptote. But does anybody remember how to find it?
Is that what you saw for XA? Or?
You're not solving. You actually just take some values that you see and divide them. So you divide. Yes, solve for x in the denominator, but we're not going to be worried about that. I'm glad you remembered that. That's good. Divide the leading coefficients. That's exactly right. Okay. Now, case 2. Okay. What if the numerator's degree is less than the denominator's degree? Okay. Now remember, in this case here, if the numerator's degree is smaller than the denominator's degree, couldn't you also read that as the denominator's degree is larger than the numerator's? Yeah, it's just a different way of saying it. But if this is a case that happens, you're going to have another horizontal asymptote. Okay, but this one you don't have to do anything fancy. Immediately, it's got to be the x-axis. So we know y would have to equal 0. That would be the horizontal asymptote. Now, there's only one other case. Is this kind of seeming familiar?
Yeah.
Okay. What was the third case? Case 3. The denominator is going to be the smaller of the two. So I'll go ahead and say, I'll go ahead and write out the same thing. So the numerator degree is greater than the denominator degree. Okay. Now in this case, this is the only time if the numerator's degree is larger, then this is when we have a slant asymptote. Okay. Now I'm not going to be worried about finding the slant asymptote unless anybody just wants to remember that process, but you would have to use long division. Or I might have taught you synthetic division. I can't remember. Did I teach you both?
Yeah.
Okay.
Synthetic is like when you have that one.
Yes, the one number in that little half box?
Yeah.
Yes, absolutely. Okay, good. So these are my three cases. Okay. So if there's a horizontal asymptote, this is going to converge. That means it's going to approach a specific number. Whatever the horizontal asymptote is, that's what the sequence would approach. If it's a slant asymptote, then we'll say it diverges because you're not going to approach a specific number. In fact, you're just going to approach infinity or negative infinity. You're not going to approach something specific. It's just a general idea. Well, let's take a look at number one now. Now, I will go ahead and tell you that the degree of a number is considered to be 0. Okay, so here, the degree of the numerator is 0. But when we're actually talking about a degree, we're talking about the largest power that an expression has. So what's the largest power in the denominator? 2. Okay, so this case here, the denominator's degree is larger. Whoop, if I can get that right there. So which case is this? The second one. Okay, the numerator's degree is less than the denominator's degree, or the denominator's degree is greater than the numerator's. So that means I have a horizontal asymptote, and it is y equals 0. So because it has a horizontal asymptote, I would say this one diverges or converges. Do you guys remember? Converges. In fact, I would say it converges to 0 because that's the horizontal asymptote. If it has a horizontal asymptote, it will converge. If it has a slant asymptote, it will diverge. It will not approach a specific number. Okay, well, let's take a look at number 2. X minus 2 over x minus 4. What's the degree of the numerator? They're the same. The degree of the numerator is 1. The degree of the denominator is 2. See, they both have 1 as a power. Oops. I don't know why I put 2 there. Sorry. Just saying if you guys are paying attention. More likely trying to see if I was paying attention. So this is what case? Case 1. So all I need to do is divide the leading coefficients, and I have my horizontal asymptote. So yeah, 1 divided by 1 it'll equal 1. So would this converge or diverge? It would converge. If there's a horizontal asymptote, it converges. So in this case here, it would converge to 1. Whatever the horizontal asymptote is, the value, that's what it's going to converge to. Okay. Yes, that's exactly right. You just divide those leading coefficients, the coefficients of the largest power term. Let's try 3. X cubed minus 9x over 3x squared minus 6x minus 9. Well, what's the degree of the top? 3. What's the degree of the denominator? 2. Well, they're not the same, so it's not case 1. It's the third one. The numerator's degree is larger than the denominator. So because this would have a slant asymptote, converge or diverge? It would diverge. This would not approach a specific number. Okay. Is this kind of helping from yesterday when we were talking about converging and diverging? Okay. And we'll be looking at, some more examples. So let's try this last one, 4. X squared plus x minus 6 divided by negative 4x squared minus 16x minus 12. They are the same degrees. There we go. Okay, so this is case 1. In fact, what would the horizontal asymptote be? Oh, not 1.
Oh, no.
Y equals, now, the leading coefficient up top is 1. What's the leading coefficient down below? -4. So remember, you divide those. So y equals -1/4. So would you say this converges or diverges? This one converges. In fact, I would say it converges to -1/4. So see, if I were to think of it as a sequence, if I looked at the y values as x got larger, we're going to get closer and closer and closer to -1/4, but we're never actually going to touch it. Okay. Questions? Okay, well that is the first one in the next set. So this next set I'm expecting to have 3 focus activities because we have a little more time. So at the very least we'll have 3, 4, and 5. Remember you already turned in 1 and 2. Okay. All right, so put that someplace safe. And let's take a look at this. All right, so if you will please take out the notes we were looking at yesterday, arithmetic and geometric sequences, and there are extra copies over there in the folders by Christian if we need one. Okay. So we said yesterday a sequence is an ordered progression of numbers. Okay. You know it's arithmetic if you're going to add the same value over and over again. You know it's geometric if you're going to multiply by the same value over and over again. Okay, and we had 2 different types of formulas. We called them recursive and explicit. Which one did we prefer? Explicit. Now, recursive depends on knowing the previous term. So if I wanted the 15th term, I would have to know what the 14th term was. So basically, I would need all the terms 1 through 14, and then I could get 15. But if I have an explicit formula, I can immediately jump to that 15th term, whatever term number that I'm looking for. Okay. And then, we had a few more definitions here. The geometric, we have what's called a common ratio. That's what you multiply by over and over again. That value is r. The arithmetic sequence has what's called a common difference. That's what we add over and over again. We refer to that as D. So D is the common difference, and R is what we call the common ratio. And I think this is where we stopped yesterday. Oh, okay. Oh, let me. It's okay. Good. You want to go? Did you get the other ones as well? You got those? Cool. All right. Okay, so we got here yesterday. Now, there are 2 explicit formulas. You could use these guys up here. C equals the first term minus D, and then the nth term, A sub n equals dn plus C. I think your best bet is just to use this guy right here. If you're dealing with an arithmetic sequence, A sub n equals A sub 1, the first term, plus n minus 1 times D. D is your common difference. That's going to be the best way to go. Now, if we're looking for recursive, this one here right in the middle is probably the one you're going to want to go with. I would recommend those 2, even though they can be written differently. Okay, so let's get to a problem. Let's see what you guys think. Now, one other thing, you're going to notice a lot of terms that have subscripts. That subscript, that's the variable n, but it also tells you what term number you're looking for. So if I were to give you A sub n, okay, what term number are you actually looking for? That'd be the 9th term, yeah. I know that for this, n would equal 9. Remember, n is the subscript. Okay, now the fact that they changed this next one to variable b makes no difference. It says find the first 6 terms and the 100th term for the sequence defined by these conditions. Okay, so b sub 1 equals -3. So what's that actually telling me? There you go. Because that subscript is 1, the first term, regardless of the variable, first term is -3. So I'm going to put -3, comma. So we want the first 6. Now, this right here, it says b sub n plus 1 equals b sub n plus 10. That's a recursive formula. So in order to find the second term, I would need to know the first. In order to find the third, I would need to know the second. Okay, so let me show you what I mean. Let's say I want the second term. Okay, so I'm going to go ahead and plug in what for n. Okay. Well, let's see here. I'm going to plug in 1, right? Because what's b sub 1 plus 1? That's 2. That's equal to b2, the second term, but it's equal to b sub 1 plus 10. You see how all I did was plug in n equals 1? So I have to use the first term in order to get the second term. So I just plugged in n equals 1. Okay, but what is b sub 1? Okay, so I'm just going to replace b sub 1 with negative 3 plus 10. And what's that give me? 7. So I know the second term has got to be 7. So now I want the third term, so I'm going to need to plug in 2, because I need the second term to help me with this, right? So this would be b2 plus 1, which is equal to b sub 3, but b sub 2 plus 10. Okay. And for b sub 2, we found that to be what? 7 plus 10, which is 17. Okay. Does everybody see how I'm generating it?
Yeah, it's like following stats pretty much.
Yeah, that's exactly it. Now, at some point, I mean, we could even go ahead and continue to plug in, but does anybody recognize the pattern? Yeah, all you're doing is just adding 10, right? So once you recognize what the pattern is, or even if you see that straight off, you at this point, you're probably going to start to realize that that 10, that's your common difference. That's what you're adding over and over again. Okay, so once you realize the pattern, you don't have to plug in anymore. What would the fourth term be? 27, 27, 37, 47. So there are the first 6 terms. Okay, easy, right? Nothing to it. Now, do we want to do that all the way until we reach 100? Probably not. Okay, so we're going to want to use a explicit formula. So we're going to have to come up with him. So this is the explicit form we always start with for arithmetic. To find the nth term, we take the first term plus n minus 1 times d. Okay. Now, every time you want to find a formula to give you any term in the sequence, okay, don't substitute for n. Don't substitute for n. Plug in every other variable you know, but don't plug in n. Because what we're going to try to do is come up with an expression for a sub n. Okay? So, like, for example, do we know a sub... Well, now, even though it's b, I went ahead and reverted back to a's. That changes nothing. Do we know the first term? What's the first term of the sequence? Okay, it's still negative 3, right? Would it be better... I mean, I always go back to a's, but would it help if I went back to b's for the problem? Okay, I'll go ahead and do that. Remember, the variable itself doesn't matter. Okay, so b sub 1, we know that's negative 3, right? We're not going to plug in for n. What is d? What am I adding over and over and over again? D is 10. So see, we have both of those. So just plug them in. B sub n equals the first term, negative 3, plus n minus 1 times 10. So all I want to do is just simplify this. How would I get rid of those parentheses? Okay, so what does that start with a D? Okay, distribute. So B sub n would equal negative 3. So 10 times n is 10n. 10 times negative 1 is negative 10. So let's see. 10n. What's negative 3 minus 10? Negative 13. This should now give me any term number in the sequence that I want. Okay, that's my explicit. So let's test it. We just went ahead and put out the first 6 terms, right? So here's the first, second, third, fourth, fifth, sixth. So let's say n equals 6. If I were to plug n equals 6 in here, I should be able to get 47. Okay, well, let's see. B sub 6 equals 10 times 6 minus 13. Well, what's 10 times 6? 60. Minus 13 does give me 47. So our formula works. But now it wants me to find what? Okay, so how am I going to find the 100th term?
Oh, plug in 100.
Plug in 100 for n. That's exactly right. See, that's why the explicit is so nice. Okay, so b sub 100 is equal to 10 times 100 minus 13. So what's 1,000 minus 13? Okay. That would be the 100th term. That's it. How we doing? Okay. Questions? All right. So let's try another example. Number 2. It says find the common difference. Okay. So remember, the common difference is D. We want the 10th term. So that would be A sub 10. Okay. And I always revert back to A. You might even see in some textbooks or resources, they might use the variable U. Again, that doesn't change anything. We wanted a recursive rule and an explicit rule. Okay. So let's go ahead and start listing everything. What's the first term? 5. So I know A sub 1 equals 5. We already have that one. Okay. What's D? 3. You can tell that easily. Remember, yesterday we said take a pair of consecutive terms, those that are right next to each other, and just subtract them. So 17 minus 14, that's 3. 14 minus 11, 3. 11 minus 8, 3. So that number you get over and over again, that's your common difference. Okay? See, and that's why we call it the common difference. It's common to every one of them, and you found it through subtraction. We're not creative when it comes to naming things. Okay? All right. So we got the common difference. That was easy enough. He's out. Now, we want the 10th term, but in order to find the 10th term, I mean, we could go ahead and just continue the pattern, but we'll go ahead and use our formulas. Okay, let's go ahead and get the recursive out of the way first. Okay, the recursive. Okay, now for the recursive, this is the form that I think is going to be best for you. To find the nth term, I want to find the a sub n minus 1 term. This is the previous term plus d. Okay. The recursive formula is very easy to set up. There's never any manipulation or simplifying like the explicit. Okay. There's just a couple things that you have to do. In order to find the nth term, I'm going to take the previous one. Well, what's d? 3. So I'm just going to add 3. Okay. I'm just going to go ahead and add 3. There's my recursive formula. But there's just 2 things you have to make sure and do with the recursive formula. It always needs the first term, and it needs to know what your restriction is. So here, I know that the first term was what? 5. And I'm going to go ahead and say that n has to be greater than or equal to 2. Okay. Now, let me go ahead and explain this real fast. If you go ahead and use this form for your recursive every single time, then every single time your restriction is going to be greater than or equal to 2. Because let's say I go ahead and plug in 2. I want the second term. Well, what's 2 minus 1? That's 1. See, I can find the first term, right? We were already given it. But what if I said n equals 1? What's 1 minus 1? 0. So there is such a thing as what we call the 0th term, but we are not going to mess with that. Okay, we're not going to be using that in here. We're always going to start with the very first term. The first term is number 1. Okay, and that's it. There's your recursive. Okay. Now for the explicit, we're going to go ahead and do exactly what we just did a moment ago. Okay. We had a formula, the nth term equals, what was the formula again? I always forget. What term do I want to start with? A sub 1. And then I add what? N minus 1. And then we multiply that by the common difference d. So if I want to come up with an explicit formula that's going to give me this, remember, I don't plug in for what? N. If I'm looking for the formula, don't plug in for N. Okay. What was the first term again? 5 plus N minus 1 times, what was D? 3. And see, then all we have to do is a little bit of simplifying, and you have a formula that will get you whatever term you want. Okay. We'll even go back in just a second and check the recursive formula to see if it works. Okay. So let's see, how would I simplify this? Because we never want to leave it like that. We always want an mx plus b. Distribute the 3. Okay. So this would be a sub n equals 5 plus 3n minus 3. So the nth term would be 3n what? Plus 2. The 5 minus 3 would give me plus 2. There we go. So let's check these things. Let's see if my formulas actually work. Remember, this is the first term, second, third, fourth, fifth. Okay. Let's say we want to find the fifth term. So if I go ahead and say a sub 5, okay, if I want the fifth term, you're plugging in 5 everywhere you have an n. So 3 times 5 plus 2. What's 3 times 5? Plus 2? 17. There you go. So we know it works. Now recursive, remember, you can only find the current term if you know the previous one. So let's say I want the second one. Okay. Well, what am I plugging in for n? I want the second term, so I'm going to plug in 2. Okay. See, the reason we didn't do that on the previous problem was because it was a different recursive formula. And people get really confused on that. So I like this one, where you plug in the actual number term you're looking for. So see, a sub n minus 1 would be a sub 2 minus 1. Okay. Plus 3. Well, what's 2 minus 1? 1. Well, see, all this is telling me to do is take the first term and add 3. But what was the first term? 5. And what's 5 plus 3? 8. Okay. So now let's see if we can find the third term. So a sub 3. This time n is what? What term number am I looking for? 3. Okay. So this would be a sub n minus 1 would be a sub 3 minus 1 plus 3. Well, what's 3 minus 1? So a sub 2 plus 3. Well, what this is telling me is to take the second term and add 3. Well, we just found the second term to be what? 8. So I'm going to say 8 plus 3, which gives me 11. So look, are we actually generating the correct sequence? 5, 8, 11? Okay. But see, that's the point. Recursive depends on knowing the previous term. For explicit, you can jump to whatever you want. So how would you like to go ahead and find the 10th term? Recursively or explicit? Explicit. Okay. So let's say I want the 10th term. Okay, remember it was 3n plus 2, so 3 times 10 plus 2. And Marcus, you said 32. Perfect. There we go. How we doing? Any questions? Okay. Now, this part right here, geometric sequences, we're going to skip that for the time being because I've always thought it was humorous. These next problems, not technically geometric, they're arithmetic. So I don't know why it stuck them there. So we're not going to worry about looking at geometric until we're ready for those. Okay, so we'll probably go ahead and make example 3 our last one today. Find the first 6 terms and the 100th term for this sequence. A sub k equals k squared minus 1. So here they're using k instead of n. Changes nothing. Okay. So let's say I want the first term. Okay. A sub 1. But you'll notice, what am I plugging in for k? I want the first term, so I'm going to substitute 1. Okay. So the formula says k squared minus 1. So I'm just going to go ahead and say 1 squared minus 1. Well, that's going to give me 0. So the first term is 0. Now I want the second term. So what am I plugging in for k? 2. So k squared minus 1 would be 2 squared minus 1. That is 3. Okay. Everybody see how I'm generating the sequence? I want to find the third term now. So what am I plugging in for k? So k squared minus 1 would be 3 squared minus 1, and that is 8. Okay. Now, if anybody can tell me what the next number would be without using the formula, we can do that. Otherwise, I'll just keep plugging in. It is 15. What's the next one? 24. Next one, 35. Another one. No, I'm just making sure. We almost got into that pattern where I could go, another one. There you go. But you're absolutely correct. That would be 48. See, I'm pretty impressed. You know, see, I know that stuff. I'm hip. I'm with it. Okay. But really, I mean, just look at the pattern. K squared, that's a perfect square, and then all you're doing is subtracting 1. So think about your perfect squares. You got 1, 4, 9, 16, and so forth. And then if you just subtract 1, see, you're getting the sequence we need. Okay. But what I would probably go ahead and do in order to find the 100th term, I'd probably go ahead and plug in. So A sub 100 would be k squared, so that's 100 squared. Okay. Now, is that 1,000 or 10,000? That's 10,000. Okay. I got 99 problems, but math ain't one. I know it's 9,999, but I stand by my joke. There you go. Oh, I know. The song says something else. Yes. Okay. Oh, I thought you were talking about the math portion of that. Yes, I know the song says something very, very different. Horrible, but no. Okay. No. I heard itch. That's all I got. She got scratch. That's all I heard. Okay. Yeah. Okay. So we're going to go ahead and stop there for today. Thank you, guys. We'll pick this up again tomorrow.